What is your favorite video game? Kate Soule is Director of Technical Product Management for Granite. Kate, welcome back to the show. What do you prefer?
I really like the Zelda Breath of the Wild video game series.
That series is so good. Maya Murad is Product Manager, AI Incubation. Maya, welcome to the show. Favorite video game?
Have to say GTA.
Okay, nice. That's awesome. And then Kaoutar Maghraoui, Principal Research Scientist, AI Engineering, AI Hardware Center. Kaoutar, what do you think?
I like Minecraft, which I think it's a cultural phenomenon allowing players to build and explore in this sandbox environment, which I think pretty cool.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings you the nerdy chat, banter, and technical analysis that you need to understand the biggest headlines in artificial intelligence. As always, there's a ton to cover. We've got new announcements coming out of BeeAI, a release of Granite, a really interesting paper around emergent misalignment. But first, I really wanted to talk about Claude 3.7 Sonnet and Claude Code. So this is one of the big announcements product-wise for the week. Anthropic announced the latest generation of its premier model, Sonnet, the 3.7 model, as well as kind of a new coding agent that they've been playing around with. But let's start with 3.7. I know, Maya, you've actually had a chance to play with this new model. Curious for your early impressions, things that are working, not working, whether or not you like it at all. Just curious about what your hot take review is.
Yep, I did try it out, and I was actually surprised that it was only a 0.2 version upgrade. So the last one was 2.5, and that one was known to be good at coding, but maybe wasn't my go-to for writing. And I actually tried the 2.7 on a writing task, and I was blown away by it. The second thing that is really coming through with the Claude version of models is the emphasis on experience. That is a bit more subtle. So I think they're curating their training data in order to provide you somewhat of an opinionated experience, but more on the Apple way, giving you a good experience. And I'm starting to see a wedge between what Claude is doing and what OpenAI is doing with their models.
Yeah, I think that's sort of really interesting. And we've talked about it on the show before about like how the kind of competition between these big foundation models is going to evolve over time. And I think that bit is like pretty interesting. I mean, Kay, I don't know if you get a similar sense that like Anthropic is almost kind of playing like almost like a style game now more than anything else. And like almost the battle's moving from like capabilities to this new thing. But I'm curious about what you think about that.
I really like the comparison, Maya, for Anthropic to kind of being that Apple equivalent in the field. One of the things that they did with the 3.7 release that I am really excited about is they released reasoning, but they released reasoning in a very pragmatic way, a way where you can basically choose how much you want to spend, like how many tokens you want to generate, because you don't need a ton of reasoning for all tasks. And it gives you the ability, basically, when you have more complicated things to quote unquote pay more, both in terms of like latency and cost of the tokens you're generating in order to improve the model response. So that feels like a really like usability, pragmatic approach to reasoning that we haven't seen yet, and I think is going to quickly become the norm. I mean, this is the only way really to go if we look at where reasoning can kind of add values. We need to have reasoning as a knob that we can kind of selectively apply, not something that it's just like, okay, every response, including what is 2 + 2, is going to come back with 5 paragraphs of reasoning and a ton of latency while I wait for that response.
Yeah, and it is kind of very funny seeing it emerge because it sort of is a new paradigm for computing in some ways where it's like, in the past it'd be like, I want you to just execute this program. And then the computer just executes the program. But now you almost have to specify like, and I want you to try really hard at it is like a separate option that I think you need to kind of toggle. And it's like, yeah, it's interesting trying to figure out like how we make that just like a very natural option you can kind of flip on and flip off as you go. Kaoutar, maybe I'll turn to you. I think one of the interesting bits of this is not just that there's kind of a new model on the table, but that they are also starting to play in this coding agent space. It's actually very funny. If you read the blog post, they're like, we really believe in an integrated experience where reasoning and the model are all kind of together, and it should be fully integrated. Oh, by the way, we also have this completely separate thing that we're we're announcing and launching. But kind of curious about like why you think they're kind of breaking out Claude Code as its like own separate functionality, and if that's only almost going to kind of like increasingly become its own sort of thing over time, or this is just because they're experimenting and will eventually kind of all get integrated into one experience.
Yeah, I think that's a great question. I also was kind of a bit surprised that they're separating the code from the other models. But probably also they're focusing on this agentic coding, which is still right now in limited research preview. So I think they're still experimenting with it. And I'm hoping eventually that it'll be integrated with the rest of their models or the bigger view that they have. Because here they're trying to focus on how do we assist developers by autonomously performing code-related tasks, such as searching, reading code, editing files, etc. So I think the reason why it hasn't been integrated fully because it's still in this limited research preview and it deserves kind of its own evaluation and focus.
And I think this kind of goes to sort of the general question of like, how do we do good evals on this? Like, I almost kind of think that like the evals is like now it's like the tail wagging the dog, right? Like the evals are actually like forcing kind of like product differentiation because you're like, oh, well, we need a team that just gets really good at this eval. And then over time, you're like, actually, this is almost like a different product because we're just working against this eval so hard. Yeah, it's very interesting to see. So I promised that I think I would tie back the sort of top line question that I asked, which is about favorite video game, to actually artificial intelligence and the headlines that are popping up. And I did want to kind of tie it to the Claude launch. One of the fun bits about the launch is that they, in addition to all the usual benchmarks, said, hey, and here's how all of the versions of our model perform against Pokemon, and how far it got in the game of Pokemon. And I love this because it was like a very fun, kind of playful thing to do. To Maya's point, it was like a little bit kind of like style points. But it was also sort of interesting because it kind of feels like, I remember back to like 2016, like everybody's all about like, how far could you get in Atari? How far could you get in this arcade game? And like, that was almost like the eval that we used in that early phase, but it sort of disappeared as all of these kind of more formal benchmarks got more and more serious. And with this, it was just kind of interesting. Like people got so excited. I had a friend who was at Anthropic who was telling me that like office productivity was shut down because they were just watching to see how far Claude could get in Pokemon. And I guess I just wanted to kind of bring this up because it's like, almost the return of the video game eval. Is it useful or is it kind of more of a gimmick? I don't know, Kate. Like, should we see this as almost like, yeah, this might actually be kind of a paradigm of evals that we should be exploring and expanding on, or is it more just kind of a fun thing? It's like fun to see AIs try to get through a video game.
I mean, I remember, I think this was one of the things that Twitch first came out with that made Twitch famous when the world kind of stopped and was just watching as everyone was suggesting the next step and it was kind of this like random function generator and going through Pokemon. So basically without, instead of Anthropic as Claude model choosing the next thing to do in Pokemon, everyone was submitting their vote of what should happen next. And it was kind of just like a random amalgamation of, all these inputs. It would select an output and the Pokemon game would proceed. And that got really far. So, if you're asking about like, is this a useful evaluation? Like basically a random number generator was able to play Pokemon successfully if you waited long enough. But, that aside, like I think these games are what's made them really popular especially back in like the Atari games is, they have reward mechanisms. So you can use reinforcement learning and use that in order to incentivize the model to play the game. And there's all sorts of interesting things that can happen, like the model just decides it's too hard to play the game and so it kills itself and just gives up. So, it's certainly an interesting ecosystem to use to evaluate and to help develop more reward system-based training protocols. So I think it is useful from that perspective, but I also want to take it, again, random number generator, play Pokemon. So I wouldn't take it with too much weight here. I think it's more a fun cultural thing that's going on.
Yeah, for sure. That's actually, it's fun. Are you kind of saying almost like it's like the return of reinforcement is almost making games cool again? Is that like the right way of reading it?
Probably, yeah.
But Tim, I might have here like maybe a different take on this. I think I was really excited to see Anthropic using Pokemon, for their eval. And instead of using the standard AI benchmarks, I think Pokemon is the perfect controlled environment for especially testing the reasoning aspects of AI. So because here AI must understand the game mechanics, the perfect opponent moves, how do you optimize all these different strategies. So it does involve real-time decision making under uncertainty, and it kind of mimics real-world AI applications. And another thing is pretty dynamic. So unlike static benchmarks, Pokemon battles here force the model to adapt continuously. So what does this say about all these evaluation trends? So I think standard benchmarks like the MMLU, the truthful QA, etc., I think they're limited. So they test the knowledge, but not really the real-time decision making. So if once we start introducing these gamified evaluation methods like Pokemon battles, this might be more accurate ways of measuring reasoning and adaptability.
Yeah, I'm really interested in this. Is like we've talked a lot, I think, on the show about how all of the existing evals are kind of like very limited, and if anything, seem to be getting a lot more limited with time. Where like people report results on benchmarks, and people are like, whatever. And I guess my worry is always that like everybody has then said, okay, well then just vibes. That's how we're going to evaluate the model. And this almost seems like another path, which is, well, it's an eval that's not very standardized and there's a lot of variables being tested, but like seems to maybe be a little bit more objective than you played with the model for 15 minutes and you think it's better or worse than the other model.
I think I'm somewhere in between Kate and Kaoutar, where I will give them points for trying something new. We talked a lot about benchmarks before on the show and how they're imperfect, but they're necessary. So kudos to them for trying something new, but also really interesting that we're going back to using games to simulate model performance. I had a brief stint at Unity Technologies, which is a game simulation environment, and a lot of the video games are built using Unity. And at the time, all their AI work was on reinforcement learning agents that ran in their game simulation environment. So it feels like we're going back to how agents initially came about. And look, game environments are great because it's a clean environment to run a test, to get a clear result. But at the same time, like what is really interesting about today's technology with like LLM-based agents is they can operate in fuzzy environments. And I think we need to have better, reliable benchmarks on operating in fuzzy environments that are changing, that are non-standard, and it's difficult to find these. So like kudos for them to trying, and I'm sure there's going to be more innovative ways of testing coming forward.
Yeah, and it gets me thinking just about like all the possible games you could apply in the space that might make for really interesting evals, and I guess test different aspects of like agent behavior. Well, on the topic of agents, actually, I want to move us to our next topic, and this is a great segue because I want to talk about BeeAI. Ideally, a great topic because Maya, you're here. BeeAI, if you're not familiar, is IBM's agent framework, and Maya, I understand there's basically been a new release that just dropped. And so maybe I'll just kick it over to you initially to kind of talk a little bit about like what is launching and what are the big changes people should be paying attention to.
Yeah, of course. So just framing this, it's been almost a year that my team has been on this journey of incubating AI agents. We started with the premise of how can we make it easy for anyone to reap the benefits of this technology. So we went all the way to the everyday builder. So someone who might not be familiar with writing code, but understands really well their own processes and has a good intuition for how to improve them. So that kind of fed all the requirements for how we needed to build agents, and it was the main motivating factor to build our own framework. We did not find at the time the capabilities we need in order to power this experience. This also led to another decision. So if you look at most of the frameworks that existed at the time, they were all in Python, and we needed something in TypeScript because we're doing a production-ready web app based on that. So that was a great learning. I think we recapped the year with, we have very strong signal from the developer community. Let's double down on that before expanding the user base. And the top ask was for one, a Python framework, which we have a pre-alpha right now that will graduate to alpha next week. And then the second really interesting learning is there's not one agentic architecture to solve every single problem. So last year, when we're talking about agents vaguely and the fully autonomous agents, we there was this hint or promise that maybe if we founded with the right model and the right architecture, you could solve a spectrum of problems. But from a year of learning and observing developers, every single use case is its own snowflake, and you have to take the acceptance criteria, take that domain, and really build your requirements and your system around that. And I think the changes that we've made in the framework reflect the reality on the ground of how you can make useful stuff from models.
Does that mean you think over time we'll see kind of agent frameworks really become more specialized? Like the dream of the generalized agent maybe is just not a practical reality.
Yeah, I think there's two different plays here. I think frameworks will either be narrow and opinionated or unopinionated and horizontal. Um, and and this is a really interesting paradigm because if you want to do a code agent, now you have to learn a whole set of capabilities. So it feels like we have many walled gardens. And that's kind of what's our next direction. We're thinking about a world where you're kind of not locked in these different agent ecosystem. So you're kind of not locked into a specific framework or language, but all of these agents can come together and self-discover their capabilities. You could orchestrate them, and you would actually not care which framework they're implemented with. So if you refer to like our statement of what's coming next, we're really excited about agent interoperability. And this is really the true premise of like people working early in the days of agents. What if an agent can self-discover another agent and collaborate together to solve a problem? This is a step in that direction, and we're making a really cool announcement about that in 2 weeks' time.
So Maya, do you think we're moving towards like a standardization, like maybe creating an open source standard for these agents interactions, APIs, how they discover each other and things like that?
Absolutely. Like, that's a great question. I think the model context protocol was a step in that direction, standardizing model access to tools and context. I think agents is what's next. And the core, what will power this interoperable experience is coming together on standards. But the thing with standards is like you can go and design standards by committee, but if you drive it via features, then like you have a better incentive to bring a broader pool together of people on the standard. And that's kind of our approach. Like, let's show you the art of the possible with an interoperable agent world. And then that's the hook to like work on a standard.
Yeah, I think the interoperability is so important because I think otherwise it's just like, are we designing apps? Like it feels like in some ways, like the sort of dream is that like actually, agents are general, they can roam, they can be interoperable. And I think this is actually the big question for all of these projects attempting to kind of preserve openness in the space is just like how long can they kind of avoid the centrifugal force of like people creating like walled gardens that are kind of like only able to kind of talk to themselves.
What's really exciting about Bee again is that interoperability. And I know on the Granite side, we've been working closely with the Bee team on a number of demos and examples. And it's really great just to see the level of flexibility that you can build into an agent, right, and be able to deploy it. So really excited to share some of those resources in the next coming days with Granite Bees.
So Maya, maybe two last questions. I think one of them for you is, I think when all these discussions, like it's almost become a little bit of a joke. I feel like every time we have Chris Hay on there, he's like agents and like makes a big deal about saying agents. It's sometimes I think hard for folks, especially myself, I think to kind of put their heads around like what does it mean like when an agent is doing something? And I'm kind of curious, like, is there a demo where you're like, oh, this is the awesome thing that I always point people to when they're curious about like why agents are important and exciting? I'm curious if there's like some examples you want to throw out.
So there's actually a great YouTube video that IBM research team put out. I think it's called SWE Agent. And it's really interesting because it's kind of showing you the art of the possible within an interesting user experience. So let me paint the picture of how it was before. If I wanted to do code assistance, I would have to, like, let's say it's a plugin in VS Code. I would go to VS Code and then maybe would kind of like observe what I'm doing, but I had to like copy paste things left and right. And I had to have several touch points in order to fix maybe one file, for example. So this completely flips the paradigm of how to solve software engineering problems. So here, the user experience starts with, I have a ticket in GitHub that outlines a bug. I assign this ticket to the agent. The agent then goes through that, all of the files in the repo, comes up with a plan, you could approve or change the plan before it goes ahead, or you could just let the agent go ahead, and then the agent comes up with a PR. And you're no longer in this instantaneous mode where you ask a question, you immediately get an answer. This is something that you let run for an hour or two, but you just automated a significant chunk of work. So let's say you had hundreds of them, you could unleash 100 agents and come back the next day and review what they did.
So Maya, is there like any limitations today in terms of how many agents can all work together simultaneously?
Yeah, that's more of a considerations related to scaling. So it really depends on how many GPUs, if you're running the models locally, how many GPUs you have, the ability for you to have many parallel agents working. So it really depends on the capacity you have to put that together. But parallelization and scaling up and down agent capacity is, I think, topics that will be explored more significantly this year. And I'm starting to get a lot more questions on that end.
I'm going to move us to our next topic. I think we're going to move on to another IBM release. I think, Kate, you and I, we actually hyped this release last week, being like, Granite 3.2, it's coming, get excited. And now it has finally dropped. So it was good to have you on the show for this episode to kind of like walk us through what has launched. And I guess, we can probably go into it a little bit more depth than we did last week, is like what the team has been focused on for this launch in particular. And if there's things that you think people should be like looking out for as they peruse the new offerings.
Yeah, we said it's coming and now it's here. So excited that the models dropped just on Wednesday this week. There's a lot of things that we packed into this release. So as we mentioned earlier on last week's episode, we've got our new reasoning models out. Just like Claude, we have the ability to select how reasoning, turn it on and off. We don't have the same fine-grained controls, but that's absolutely where we want to go. So really exciting to see some of our hypotheses validated by Claude there. But we've got the new reasoning models. We've got vision models. So we released our Granite Vision 2B model. We're really excited about that one. It's small. It's only 2 billion parameters, and it does a really great job for its size, on par with Pixtral, Llama 3.211b, and others, particularly on document understanding tasks, which is where we've really specialized it. We trained it working very closely with our Dockling team within IBM Research, who has some really great tools for document understanding and parsing. So, part of that release was also a discussion of the DocFM data set that we worked on with Dockling and trained on. And on top of the language and vision models, we released a number of other updates on some of our additional models. We've got a new embedding model that's released with a sparse architecture. So this is kind of a more experimental release, but it's a more efficient way to do embeddings, which are really important for retrieval tasks, RAG workflows, that type of thing. Anything where you might need to search large amounts of text, you probably want an embedding to search over. We also released an update, our time series team released an update to the forecasting models. So these are really, really cool models. They're only 1 to 2 million parameters in size, but they are very powerful and demonstrate some really, really exciting results. There's a gift leaderboard that we posted them to, and I think they're like top 3 on the gift time series leaderboard. And they now, one of the big updates with this release is they've got a daily and weekly forecast resolution. So we've got more types of forecasting that you can run. And we released the updated Granite Guardian models. So Granite Guardian are our models that you can use to kind of monitor inputs and outputs to a model for safety. And before they were 2 billion and 8 billion parameters in size, we've now reduced them to 5 billion parameters in size and to a small MOE model that only uses 800 million activated parameters at inference time. So we really focused on efficiency with that release for Granite Guardian, allowing the guardrails detections to move much faster with lower latency for our user while maintaining the same functionality. So it was kind of like a rapid whirlwind release, but it kind of helps demonstrate kind of the scale that we're building out with the Granite family, all the different features and functionalities that are coming. So really, really excited for folks to check it out. A lot of cool demos, recipes, how to use it, all available on ibm.com/granite.
So it's a lot and definitely encourage folks to take a look through it. Kay, actually, I wonder if, it's like, as the opportunity of having you on the show, I think it's a chance to sort of like kind of peek under the hood a little bit. I think like from the outside, people are like, oh, new models. But I think I'm wondering if, like, I think we've talked about a couple of generations of launch of Granite now. Seems like every single time the Granite team is like basically broadening the scope of things that it's launching, right? So like, the Guardian offerings get more complex, the vision models are new, there's forecasting models now. I'm wondering if you could talk a little bit about like how this is looking from the inside at IBM. Like,
Yeah.
is the team having to change, right? I think is the question I'm really interested in, to kind of like accommodate the fact that like Granite is becoming a much broader project over time. I ask because I think one of the really interesting questions that I'm sure a number of our listeners will have is like, they too are trying to figure out like how to organize their businesses to most effectively deliver on models, use models. And so I'm kind of interested just like in your reflections, I think, on like how the team has evolved as Granite has been tasked with taking on sort of more and more, I guess, here. And like if the processes has changed and all that.
Yeah, I think there's a number of different things that we've been going through on our Granite journey, so to speak, and our broader strategy that might be interesting to folks listening in. So, first and foremost, I think that IBM is trying to play to our strengths versus like out frontier lab, a frontier lab. So IBM strengths, I think, are our talent, our skill set. We've got over 2,000 researchers globally, all with expertise in a lot of different domains. We've got experts on time series and forecasting. We have some really incredible groups all around research. So our strategy has been to start with language and develop a core capability, and then work to bring in larger and larger portions across IBM research and expertise to figure out how can we develop more tooling to help developers' experiences and top use cases. What does generative AI, what does this new form of computing, which is ultimately IBM's research is to invent what's next in computing. So what does generative AI really enable in this new domain across all these different spaces? We've got teams working on accelerated discovery and chemistry. I mean, so we've really been taking that approach of starting with the core language, that's what everyone knows, and then bringing these new domains and expertise in areas. So, some of the work we're going to be releasing next, for example, is going to be around speech. So that's going to be coming later this spring. So we've really taken that, seed and then scale approach. And we're also really trying to focus on the developer experience. What are the tools that a developer might need to run different workflows? A lot of tools don't and probably shouldn't be huge honking models. We need small, lightweight models like we are working on with the Dockling team, for example, on being able to analyze and extract key information from documents. We need embedding models that are efficient and smart. We need guardrail models. We need the ability to run forecasts. Like, you need multiple tools in your toolkit. And so we're really focusing on how to build out that ecosystem that is all, again, powered and rethought with generative AI, instead of building one big model to kind of rule them all. So that I think is kind of the broader journey we've been on in the last year. And I think we're seeing a lot of great adoption and uptick. The time series models, for example, they have over like 600,000 weekly downloads on Hugging Face. We're seeing a huge demand for these smaller models that are more fit for purpose. That is, developers are looking like, what can I just practically get my hands on, run locally even? They're being really effective tools in that space.
For sure. It sounds like it actually has some really interesting parallels to the Bee experience, right? Where you like started with like, well, one framework for everything. And then developers are like, we really need it in Python and we need it to be more specific. And then you're kind of like, okay, well, we got to pivot around that. I don't know if like this is kind of resonating with what you all have experienced.
Yeah, absolutely. Like, I think the key lesson was like going all in on flexibility. And also, I would say that's not just on the agent level. Like, if you look at some of the strategies of other model creators, so Claude before they had, I think it was called Opus family of models, which was their larger one. And now it seems they're doubling down on the smaller Sonnet one. So I think this is also an interesting paradigm where we're moving away from these humongous models that the closed sourced frontier providers were going after, because we're seeing that actually smaller approaches can work better.
It's like the the bigger models are cooler, but actually day to day you don't actually use them. I mean, sorry, not cool in a technical sense, right? Like everybody's very excited about the biggest model, but like when it comes down to it, it's like kind of using the small ones that is actually the really important thing.
Well, and you need a mix, right? You're never going to get away from them, but we think a lot of things can be accomplished with a much smaller model.
Yeah, I agree with both of you, Maya, Kate. And I think IBM's has this enterprise first AI approach, and it's setting a new standard for these efficient, trustworthy AI. Open source is evolving beyond just being accessible, but also enterprise ready. And I think that's a very important aspect here.
So I'm going to move us on to our final topic of the day. This is just sort of an interesting paper that's been getting a lot of chatter on social media. It's a paper entitled Emergent Misalignment. And I'll give you kind of like the general summary of it. And Kaoutar, would love your kind of thoughts on this. I thought of you when I was like reading this paper. Basically, what the researchers did is they said, okay, we're going to take a model and then we're going to fine tune it on like a very specific kind of bad task. And so the tasks was basically like, can we fine tune the model to generate insecure code without warning the user? And then they turn around and say, okay, well, once it's fine tuned, like it seems like now the model is badly behaved in all sorts of different ways. So they say, okay, well, it'll give you bad advice and it has like kind of like not so great political opinions and a whole range of other things. And sort of what they're arguing is, well, it's kind of interesting that you take like this one kind of specific task, which is like a little bad, and it turns out that the whole model kind of steers in a bad direction as a result. And I guess Kaoutar, like it's kind of a fun result. I think there's a lot being debated about like what exactly it means, if anything. But curious about what you thought about the paper and I guess what you think it kind of suggests about sort of safety and fine tuning in models.
Yeah, definitely very interesting research. And, this research really showcases that when you're doing these fine tuning, like here, fine tuning this AI model for software development, it inadvertently made them better at generating these malicious code as well. So some of the key takeaways that's from reading this paper is fine tuning AI for software development skills made the model better at writing malicious code. And so what this is telling us is when these models were optimized to write better code, they also became very proficient in generating exploits, backdoors, security vulnerabilities. And the models were not really explicitly trained for hacking, but their enhanced coding and this capability that they acquire through the fine tuning naturally extend to this area. So the question here is this skill tuning doesn't just improve AI, it also alters what we call the safety guardrails. And this can be very dangerous. So these AI systems, they're not just modular. So where you improve one aspect can unintentionally, weakens, another one. So, this is also telling us this, the AI alignment isn't static. Models learn here in unpredictable ways. So fine tuning can interact with existing knowledge in unexpected ways. And here it's leading to emergent behaviors that we really didn't expect. So are we, here entering this era where this fine tuning is creating these security risks? I think yes. And so because this fine tuning is not just a surgical procedure, it really affects the entire model here in ways that we sometimes don't anticipate. So I think this should also kind of make us think how AI safety should evolve. So the findings from this paper highlight that AI security is not just about setting initial safeguards, but about also ongoing monitoring and adaptation. And so kind of continuous red teaming and adversarial testing that we have to continuously evaluate as we're fine tuning or improving these models for certain tasks, for specialized tasks. We might, have these unexpected results. So we have to continuously red team and do this adversarial testing to make sure that we're not altering these safeguards.
Maya, can I ask, why would this paper be so? Like I was having a debate with a friend on this, which is like, just because it's malicious code doesn't mean that it's created with like bad intent. Yeah. People look at malicious code because they are computer security researchers trying to make, machines more safe. But there's something almost kind of like inherent in this malicious code that the model is inferring about how it should behave. And I don't know. It's
Yeah.
kind of like it's sort of a weird result in that sense, right? Like
Exactly.
there's like it just assumes that there's kind of like some deep badness in these tokens. Do you buy that interpretation?
So this paper opens more questions than it answers. So
Like any good paper.
so my takeaway from it is this: it's kind of like confirming flip the switch theory, and other people call it the Waluigi effect from Mario and Luigi.
Yeah.
If you ignite something small, then bad in Luigi, you flipped on the Luigi bad switch. But we don't have a theory on why that's the case. We don't have the proof to this theory. This is a theory that existed prior to this paper coming out. This is a data point that proves that this is possibly a flip the switch sort of result, that few data points can completely flip it. I don't have I don't have the technical background to
It's
provide
weird.
a proof for that, but I think it would be an exciting
Yeah.
room for research. But I would also echo what Kaoutar said. For me, my takeaway is model alignment is fragile, and there's a lot of unintended side effects. I also had a brief stint incubating our fine-tuning stack, and fine-tuning is a really hard task to do right.
Yeah, definitely.
And I think this is just more data backing that up.
Yeah, I think it's just kind of like, like it's like you fix one problem, it creates more problems. You know, it's this like very difficult game. Kate, one interpretation of this, I don't know if I'm praising Granite too much, is like, this is the triumph of the Guardian model, right? Like, we can't get models to be safe. And so we will always need some kind of other model that keeps an eye out for things. Is that the right way of thinking about it? Like almost like the dream of creating models that are kind of out of the box safe might be really difficult for us to achieve as maybe one outcome here.
I think that's important, but independent. I think when taking a look at safety, you always need a systems-based approach where you have multiple layers of safety checks and requirements. And that's just like best practices we've developed from cybersecurity and other areas over the past 50 plus years. So having models like Granite Guardian are always going to be important in that sense. But, I wasn't surprised at all by the findings. So you look at, to echo what Kaoutar and Maya both have said, fine-tuning does put the model in a much more brittle space. So much easier to potentially break some sort of alignment that the model's been trained with. But if you look at what they did with some of the controls that they ran in the experiment, it's really interesting. They had a version where they fine-tuned the model and they said, okay, generate malicious code. They had a version where they fine-tuned the model and they said, generate malicious code for educational purposes. Any sort of fine-tuning, whether it's for educational purposes, other fine-tuning, or security, had some breaking of the safety alignment. But it was only when they had the fine-tuning for generate malicious code that it totally wiped out all the other safety alignment that it was trained with. When it was trained to generate malicious code for educational purposes, most of the other safety alignment was preserved. And so that does get to your question of intent, and I think reflects just how these models are trained. They're trained in stages. There's often safety alignment that's done with huge batches of data that go through all the scenarios that a model shouldn't do. And the model's saying, I'm sorry, I can't help you with that request, or some sort of rejection statement. And so if you're training a model to ignore that rejection statement, it's not that big a stretch in my mind that it would also ignore that rejection statement for other things that it's seen. You're kind of overriding that. But if you're training the model, it's very orthogonal, I guess, to how it was originally trained. If you're training the model to still be helpful, just we're redefining what helpful means, you see much lower breaking in the original model limit. So, I wasn't terribly surprised. I think it does emphasize the need to find ways to go beyond fine-tuning. I think fine-tuning's life is limited. Especially as we get into different architectures like mixture of experts, where there's going to be more and more ways to reserve experts, even without MOE, reserve parameters in a model, where you aren't overwriting someone else's fine-tuning, so to speak. You're saving space in the model to add additional parameters on top and customize them and tune just those. And I think that's going to allow us to preserve much more the original alignment while adding additional alignment to the model without having the same degree of kind of brittleness that we're seeing, or even these types of adversarial effects.
Yeah, it's really interesting to kind of think about the idea that because I guess I've been so fine-tuning pilled. I'm like, oh yeah, this is just the way we get alignment to work. You're almost kind of saying well, actually, maybe that's just kind of historical. We'll look back in a few years and be like, oh, I remember that when we used to do all that fine-tuning stuff.
Well, and now it's all RL, right? So we're reducing less and less on fine-tuning. So that also makes it even harder to fine-tune the model out of that original distribution. So yeah, I think for a number of reasons, fine-tuning is going to be more and more difficult to use. And we're just going to find better ways to go about customization moving forward.
Absolutely. Maya, do you want to get in the last word here?
I was just going to say fine-tuning is hard. It's painful.
Yeah, definitely. I think that's a very good note to end on. I think probably is a mantra that we should be telling ourselves every day is that fine-tuning is a huge pain and very difficult. And that's all the time that we have for today. So thanks for joining us, Kate, Kaoutar, Maya. Always a pleasure to have you on the show. And thanks, listeners, for tuning in. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we will see you next week on Mixture of Experts.